Hello, welcome to Rangle.io webinar on why Redux is the future of Angular 2 and React. My name is Yuri Takhteyev. I am the CTO of Rangle.io, and joining me today for this webinar is Evan Schultz.
Hello.
Who is one of our developers, and we'll be talking to you about Redux. This webinar will touch on some of the topics that we've covered in some of our earlier webinars, but we'll go through them fairly quickly, and we'll go into a lot more depth on Redux. So let's get started. Well, first, what's the problem that we are looking to solve here? Let's think about a typical complex single-page application. Usually, you have lots of parts, and obviously, what usually happens is that it starts simple and easy, but as you want to add more features, you get more and more parts, and eventually you start also with like neatly separated architecture, but down the line usually everything is connected to everything else, and that means that changing anything breaks something somewhere, right? And so it makes, and the outcome of this is that it becomes very difficult for you to actually add new features, because every time you make a change, something's going to break, and it's going to take you a lot of time to figure out how to actually fix the things, like how to deal with the fallout. So we've talked about this problem before, and we've mentioned in an earlier webinar sort of the two main solutions that are kind of known as of now. And one solution to this is component-based UI. Now, this is something that was pioneered with React. It's something that is doable with Angular 1, but often wasn't done, and something that Angular 2 now really has fully embraced and makes it really easy to do. So we're not going to talk today about this, because we've talked about this in the past, and we'll be covering this idea in more depth in some of our later webinars. Now, the second idea is what we call a stateless approach to the deeper parts of your stack. Again, this is something that we've talked about a bit before, and I'll do a quick recap of things that we've said, but what we want to do today is go a lot deeper into one of our favorite approaches when it comes to achieving a more stateless architecture, and this is the Redux framework. So let's talk about stateless architecture and quickly sort of recap of why is this good and important. So a lot of us were raised on object-oriented programming, and basically building software which is built around stateful objects, right? So objects in object-oriented programming are stateful in the sense that the effect of calling a method, the effect of calling a method depends on two things. It depends on the arguments that you provide to the method, and it also depends on an internal sort of hidden state of the object. And this was seen as a good idea when object-oriented programming came about, but it actually has a couple of big downsides. One of them is that it's very, very difficult, it's painful to test such code. The reason is because you don't know, when you call a method, you don't know what you actually ought to expect, because the results depend on the internal state, and objects sort of naturally actually hide that state from you. The second is that it's actually hard to understand, to a point where you would, once you kind of understand this, the problem, the extent to which state makes it difficult for you to reason through the code, the hidden state, right? The hidden and malleable state. You start wondering even why this ever seemed to be a good idea. And of course, the reason it seemed to be a good idea is because objects were seen as sort of mimicking the structure of the real world, right? But the truth is they don't. They really, like data objects are not the real thing. Like, so when you actually do something along the lines of person, object is an instance of, manager is an instance of employee, well, they don't actually correspond to really the reality of a manager and employee in the real world. So this attempt to mimicking them usually just doesn't pay off. You really just end up replicating unnecessary complexity, and it ends up being a lot easier for you if you just don't do that. So what are some of the alternatives? Well, the most important idea in building alternative solutions is the idea of a pure function. A pure function is a function whose output depends only on inputs, and this function usually has a truly pure function has no side effects other than returning some value. You give it some inputs, it gives you an output. That's it. Now, it's a somewhat limiting way of handling functions. Usually functions we write do a lot more. They can hold state, they can do closures, they can do all sorts of funky things. So why pure functions are good? Well, they're much easier to understand, right? Because you know exactly what this function is supposed to do. It's supposed to, given those inputs, it's supposed to give you that kind of output. The second is they're much easier to test because, again, once you have this specific input, there is only one right answer. There's only one right behavior of the function, which is to give you the corresponding value. So writing tests against pure functions is a breeze. In contrast, writing tests against object-oriented interfaces is actually quite a bit more difficult. And it's also very easy to build up pure functions through functional composition. Where you can, again, so you can basically build chains of them, and you can sort of have your data moving from one function to another, where if you actually want to analyze it in each step, it's very easy to do so. So this approach is widely used on the server side today. It's being coming to the increasingly to the front end. So let's now kind of come back to a typical application and understand how state truly becomes painful, right? So you have a component and you have a model. This is the kind of your classic MVC approach. Your component updates the model, your model sends information back to component. This is so far so good, but it gets messier when you have more components and you have more models, and you start having kind of relationships where everything changes everything and you soon really have no idea what's happening. So instead, the general direction which a lot of companies are going today is the unidirectional data flow with Flux. And the Redux library that we'll talk about, it can be seen as either, depending on your perspective, a kind of a Flux implementation, or you could look at it as key ideas of Flux but taken to their logical conclusion, right? We don't want to get into an argument of whether Redux is Flux or not, but it's definitely from the same family of ideas. So in a unidirectional Flux-style architecture, what you're going to do is you're going to have a bunch of components, and you will severely restrict how they can interact with your data. And in particular, your components are going to only be allowed to do one thing, which is issue actions. Those actions are going to get collected by, let me go through a sort of a simple scenario now, and we'll look at a slightly more complicated one later. Those actions will go to a dispatcher, and dispatcher will send them to stores. Stores hold your data, and stores will update your data, your representation based on the actions, and then will send events to components to update the components. Now, the important thing here is that components do not have a direct way of touching data in the store. The only way interface to it is through actions. So this is a constraint model, but it actually makes your life a lot sane, and it also makes it really easy for you to make sure that if you have a bunch of components that are effectively displaying the same data in different ways, they're always all in sync, because if one component sends an action, then the store will update all of the relevant components, and they will all have the right latest version of the state, or at least the part of the state that they care about. This gets slightly more complicated when we actually start looking into things like into asynchronous workflows, like for instance, where when the action that component needs wants to trigger actually, for instance, requires a server interaction. For instance, the user entered some data, we want to save it, right? So in this case, what we would do, and this is practically what we need to do pretty much all the time, is we switch from the idea of components sending actions to the components triggering action creators. And action creator in this case is a function which will basically do a bunch of work, for instance, talk to an API, and then at some point get back a response from an API, and it will then trigger and dispatch an action. And it could be multiple actions. So for instance, it could be one action when the request is sent out, another action when the request actually comes back. And then the rest of this approach is actually the same. Dispatcher collects actions, sends them to the stores, and updates all of the components. So again, this is, if nothing else, this is an approach that's really the one you should be looking at. But can we do better? And so this is going to be the focus of our webinar today. Is we want to look at Redux, which is a library that can, in a way, take Flux architecture to its logical conclusion and can really allow you to do amazing things. So Redux is available at this URL. It's github.com/react/Redux. And the key concepts of Redux is a single store. And so instead of the sort of the typical Flux approach where you have multiple stores, in Redux you have just one. And you have something that are called state reducers. Now, so this raises two questions. One is, can a single store actually be a good idea? And it sounds really scary at first. And I'll come back to this question later, and we'll say, well, yes, it is a good idea. And the second question that you probably have at this point is, what the heck is a reducer? So let's deal with this second question first. What is a reducer? Because it's really important to understand what's the idea, the core idea of reduction, because then a lot of things in Flux suddenly start making much more sense. So reducer is the idea. Redux's reducers are based on a more basic idea of a reducer function, and reduce. It's actually a built-in function on JavaScript arrays that are also available through a bunch of functional libraries such as Lambda. It's one of the basic functional functions, but it's not. It's one that doesn't get as much love as some of the other ones. I mean, everyone who have even touched functional programming probably uses map. .map, so array.map allows you to take a bunch of values and run each one through a function and get an array that has the new values. There is a array.filter a lot of people use, where you basically provide a predicate and then you only get those items of the array for which the predicate says returns truthy value. And reduce is a little bit more mysterious for some people, so let me just walk through an example. So in reduce takes array.reduce takes two arguments. The first argument is a function, and that function would take two arguments. The first would be a value, so that would correspond to the different items of the array. So in this case, if we're calling the array 1, 2, 3, 4, 5.reduce, then add one value would get called first with value being 1, then with add value being 2, then with value being 3, and so on. And then the second argument is the state. So the state is something that gets passed on from one version of add one value to another, so from one call to another. So in this case, the second argument to reduce is the initial value, but the subsequent calls, the state will be the return value of the previous invocation. So let me walk you quickly through an example of how this works. So we are going through, in the first invocation of add one value, the item that we're looking at, the value is 1. Our state is 0. What add one value does is that it adds up the state. It generates the new state, which is the sum of the previous state and the value. So in this case, 1 plus 0 is 1. On the second invocation, our value is 2. This is the second item in the array. The state is the output of the previous call, which is 1 now. So 2 plus 1 gives us 3. On the third invocation, the value is 3, the third item in the array. The state is the previous output, which is 3. So 3 plus 3 is 6. Then our next item in the array is 4. The previous state is 6. 4 plus 6 is 10. And then finally, for the last invocation, we look at the last item in the array, which is 5. And the previous state, which is 10. And 5 plus 10 gives us 15. And of course, what you would notice is that this is basically the sum of all of the items in the array. So this is how we can add up all of the items using the reduce function. It's a really powerful function, just generally speaking, worth making good use of it. Now, what does this have to do with Redux? Well, action reducers in Redux are basically, the idea is the same. So we provide a bunch of functions, and each of those functions is going to take an action and a state. An action is really like a small JavaScript object that consists of a type and some payload. So we take an action and a state, and we return a new state. It's just like we were doing with add one item in the previous example. And so then Redux will basically make sure, so it will maintain the sequence of actions and will calculate your current state as a reduction over this history of actions. So in this approach, each reducer operates on a subset of the global state. they don't necessarily have access to all of it, but basically they get a slice into the state and they change it in response to an action. And then we can have a mechanism for combining complex reducers into simple reducers into complex ones. So let me give you a quick example. So this is from a simple application that manages nodes. And what we'll see here is that we call a function called createReducer, and what this function takes is a object that maps different action types to different reducer functions. So in this case, now this code is maybe a little bit difficult to understand if you're not familiar with ES6, so let me quickly show you the ES5-ish version of it. So in this case, we'll say the update node content maps to a function that takes a state and an action and returns the result of this call to state.setIn. Now we'll talk about more about the state.setIn later, but for now just get the idea that the reducer function in this case takes the previous state, the action, and it returns a new state. We want to make sure at that point that when we return the new state, that the new state is entirely, that the old state is entirely unmodified, and we'll talk about how to achieve that. But for now, let's just trust me that this code does that. So and the code I showed you earlier is really the same thing. So in this case, this is just using the fat arrow notation. So update node content is a function that, given a state and an action, returns the state, the output of state.setIn. I mean, notice that the arrow notation actually is really optimized for cases for writing pure functions, because you can actually write very simple, concise functions which have no side effect. It really is give it for this input and that output, return that value. So this function has no side effect of any. And then we have some other action that basically, well, in this case it actually doesn't do anything, or maybe we just either we do something else with the state, or rather do something else to calculate a new state, or we just return the exact same object that we received, in which case we actually just do nothing. So again, this is the simplified version of that in ES6. So action types map onto functions, each of which take a state and an action and returns the new state. It's really important at this point that those functions do not attempt to modify the state object that got passed into them. Now, why is this a good idea? Well, a couple of things. First is your reducers are pure functions. So they are very easy to understand and they're very easy to test. And this is actually very exciting because the reducers will actually end up doing some of the most heaviest lifting in your application. Like, this is where, to an extent to which you will need to be basically taking data structures and merging them together and worrying about what things are at any given point. That code is going to be in reducers, and making them pure really helps you. The second, and this is actually kind of amazing, is your reducers are synchronous. And I mean, we've been all learning over the years that in JavaScript, you can never really sort of assume that things are synchronous because everything is asynchronous and you have to be prepared to deal with asynchronous workflows. But Redux actually manages to undo a decent amount of that. Your reducers are synchronous, and you actually do not need to worry about timing while you are developing your reducers at all. For your reducers, you're just saying that when the following action arrives, if given a state, here's how we calculate the new state. It absolutely doesn't matter when that happens, timing-wise. So the other advantage, and we'll come back to that, is data logic is now 100% separated from view logic. I mean, like, this is as clean of a separation between them as we could possibly have. And you can still have modularity by combining simple reducers. So in that sense, it seems sort of scary that, well, we're having a single store, but really it's not like we actually have a single giant data structure that we're passing around. Each reducer function is provided with a slice, with a section of the global state, and can only change that, and then different parts of the application, again, you can expose to them, different components, you can expose them to different transformations of or different views of your state. So you can actually still have modularity in the state. Now, your modularity works a little bit differently because you're essentially in this approach prioritizing separating view logic, all of view logic, from separating all of business logic, and then you achieve further modularity separately within your view and within your business logic. It's somewhat different from the classic object-oriented approach where you try to put together sort of chunks of view and logic into little packages that are independent from other things, but at the same time actually have less of a view versus business logic separation internally. And another really exciting thing about this approach is that it actually opens up tremendous opportunities for tools, right? Because think about it this way: because your current state of your app is just a reduction over the history of actions, you basically get undo functionality built in for debugging purposes into your application right away, and you can do actually pretty amazing things. So let me actually give you a very simple demo of this app that I showed you. And so what this is a simple note-taking app. So we can add a note, and then we could just type in some content into it. And what we have here on this side is a Redux DevTool panel, which we have different ways of running it, but in this case, I'm just choosing to make it a div inside of my application. And it shows us the different, let me reload this application just in case. It shows us the sequence of different actions that have happened. So one thing that we'll see is that one of the actions that have already happened just upon load is we've asked our application to fetch nodes, and as a result we got our nodes back. So this is the request, and then this is the actual arrival of the result. So what we could do now is we could actually cancel it. We could basically say, what if that action didn't happen? And we'll see that, well, if this action didn't happen, we would actually not see any nodes, right? We can turn it back on. So we can now, let's go and add a node, and let's say, hello, webinar. And then we'll go and we'll actually change this to I'm going to use Portuguese for this time. So what we'll see is that for every, so here's, first of all, here's the add node item, right? And one thing that we'll see is if we actually can cancel this, then nothing else is actually going to matter, because it doesn't matter that we're updating node content. Like it's as if we don't have that node, right? So notice that what we could do here is we could actually do cancel events out of order, right? So I know that if the update node content happened but add node didn't, then node doesn't exist. It doesn't get displayed. Now, alternatively, I could go and actually, so in this case, it updates as I type, so I could go ahead and in this case, we don't actually have this working quite right, because I didn't quite implement this correctly on my side. We've created, when I undo the, when I re-trigger add node, we actually create a new node. So as a result, those updates no longer apply, which is actually a bug on my side. So let's do again. Hello, webinar. And then let me go and change this. So we can see now those actions, and we could say, okay, well, let's cancel this, right? So we can see, and so now, and then in addition to this, so this is the basics. We can go and also furthermore, I guess, is that it's not just that we can cancel them. We can also see what exactly happened, right? So we say when this event arrived, this is the action that flew by. Here is the note ID. It consists of note ID and the content. And here's what state we ended up with afterwards. So we could see that we had before by ID, so our nodes by ID, and then we could sort of look at individual items and see which was this probably the last one. It makes sense. Okay, so we'll need to find find it by ID. But the idea is we can actually see what changed in our state, and this makes it much easier to debug things. Now, in addition to that, it gets even more exciting. What we could do is we could take we could save our state, we could go back to it, we could have multiple debugging sessions at the same time, and it ought to be actually fairly plausible, though we haven't seen this implemented yet, to really share debugging sessions effectively with your coworkers, where you basically just do share and the whole state gets saved, and your coworker can go and actually get into exact state where your application was when you found a particular bug. So that's really exciting. So the opportunities for tools there are limitless, and people are just only starting to really take advantage of that and develop all of that. So this is the exciting part. Now there are some challenges, and let me cover them quickly. And one challenge that you get with Redux, for which there is actually a very easy solution, is this all works as long as you can commit to not changing state. If you change the state, so your reducers must not modify the state object that got sent to them, because now if they do, then the history, the restoration of alternative sort of scenarios no longer becomes possible. Now, how do you do that? How do you keep your reducers honest? Well, one approach is to clone the new object every time. And if you look at Redux documentation, it actually sort of makes it look like they endorse this result. I mean, they're trying to do it just to keep it simple, but I mean, the truth is that this approach really does not work. It does not work at all for any non-trivial application. So your alternative is using the library called Immutable.js. So what Immutable.js allows you to do is that it allows you to create data structures for which you could derive new versions without modifying the old one, and do all of that in a very efficient way, right, compared to cloning. So here's how an example of this would work. If you have a data object that's an Immutable.js object, and you want, like logically it will be data.foo.bar.buzz to be set to a particular value, you will call data.setIn, you will provide the path into the data structure and the value, and you get a new object. Now the interesting thing there is that at this point, the old data object is unchanged. If you were to try to retrieve foo.bar.buzz from it, you'll still get whatever the value was there. New data, however, is an object that behaves identically to the initial one, but it now has this new value. So you can now return new data to your caller, and at the same time have full confidence that you did not mess up the initial data set, and that no one else will be, that the caller who receives new data from you will not be able to mess up your data. That simplifies your life a lot. So basically, generally speaking, if you're using Redux, you probably want to be using Immutable.js. This is really kind of a key building block for stateless architecture. So this is challenge number one. Now the second challenge is handling asynchronous actions. As I mentioned, things are very simple when all of your actions are synchronous, but you do end up interacting with the server. That brings up asynchronicity. So there's a couple of approaches, and let me present here the simpler one. So in this approach, you handle asynchronous actions inside action creators. So you call an action from your UI, you call an action creator to initiate a request. The action creator then emits an action to let everyone know that we've made a request to a server, or that we're about to make one. It then goes ahead and actually makes a request. And if the request succeeds, then the action creator emits an action to inform everyone that it was completed, and sort of includes the data that we received. And the same thing for timeout and failure. And of course, what's important here is that you don't want your action creators to actually be dealing with the ugly details of making HTTP calls or even sort of post-processing data. You want to push all of that into a module. So here's an example. So we want to be able to fetch nodes from the server, and this is just the first. We're going to create an auxiliary function that creates actions for us. So we're going to be sending out 3 versions of the same action. There's going to be a version of this action that signifies that the request is being made, There is a version of it that signifies that the request succeeded, and there's a version that signifies that we've got the results back. And so we create a helper function that takes status, so requested, error, success, and an optional data object, and will basically give us a JavaScript object that we could use as our action. So that's what the output of this is, what we're actually going to be dispatching. So here's how we then implement fetch nodes. So fetch nodes returns a function that takes dispatch. So this is ES6 fat arrow syntax. So fetch node returns a function that takes dispatch function as an argument. So basically Redux will call our function and give it a way of actually dispatching actions. This is to sort of constrain to make sure that we don't have like anyone going and doing this without being invited to. And the first thing we do is we create a new action to signify that the request is being made by calling make fetch nodes action with request as the first argument. And we pass the output, the action we get back, as to dispatch. And so this basically sends action through the system saying that a request got made. Now, when we then call fetch data, and fetch data is a function that just hides all of the ugly details, because maybe it actually needs to make 75 HTTP calls just to actually get us the data we need, but in this case we don't really want to know about this. We just call fetch data and we expect to get back a promise. And our success callback for that promise is a function that takes the JSON that's returned by fetch data and creates a new action that puts that JSON as its payload with status success and dispatches that. And for our error handler, again, is a function that takes error as an argument, creates a action of type error and the error as a payload, and dispatches that. And that's basically it. Now, that's not the only approach. I mean, Redux has this concept of middleware that is a bit more complex, so we're not going to get into it. It's something that you probably would want to look into eventually. And there's an alternative way of handling this using middleware, but for now, let's stick with this simpler approach. And then so finally, one really exciting thing about all of this is that testing is super easy. So testing reducers, what we will do is we'll write a test where we will have we'll create an initial state. We'll take some metrics from that initial state. In this case, we're going to check what's the number of nodes on this. We will then, so with dispatch, no, I'm just confused by that line, the second line. Anyway, so we then take the initial state with dispatch and action through it, and we get a new, we get a new state, and we then can do a comparison. So we check that, and the point is it's really easy. I mean, we have the old state, we push an action through the system, we get back through the reducer, so we get back a new state and we compare and we check that whether the new state is what it needs to be. So in this case, we'll check that the number of nodes is one more, and that the node that is now in the beginning is the one that we actually created. It's really that simple. So now let's talk about integration. So this Redux can be used with both React, Angular 1 and Angular 2. We're not going to talk about Angular 1 today, but we're going to talk a bit about React and more in depth about Angular 2. Now, it's worth noting that it's kind of exciting that we've managed to get that far in this talk without mentioning the view logic at all. And what this means is that you can actually build a good chunk of your application in Redux before you even decide whether you want to use Angular or React, because it has nothing to do with Angular or React. Like, you can build out most of the complexity. You can build an application that is, has complicated internal, business logic that, makes all of the necessary HTTP requests, that really has everything other than very veneer on it, right? And you could do all of that without even deciding are you going to be using Angular or, So that is very exciting. And if you want to do your applications in a sort of test-driven way, then this really is a good way to go. Now, However, let's now look at how to integrate this with React and Angular. So what we're going to do is I'm going to talk very briefly about React, partly because the mapping of Redux to React is somewhat more straightforward, or at least a little bit more intuitive, and it doesn't require as much many examples. And also because we're just assuming that a lot of people in our audience are probably more interested in Angular too. So I'll talk briefly about React, and I'll skip over some of the details, and then Evan is going to go over Angular 2 in a bit more detail, and we'll see, and cover some of the things I'll skip. So let's talk about React Redux with React. So it's actually really simple. So you use a package called react-redux, and react-redux gives you a function called connect, and you use connect to basically tie your Redux to a container. Now, we've talked about this distinction in our earlier webinars, but let me quickly reiterate it. So when you're kind of going with component-oriented approach to your view, you want to distinguish between two different types of components. There are components that we're going to call components, which we also have called them in the past dumb components. So they're components that will really strictly receive their inputs as incoming properties, and will only sort of do the only thing that they're going to do themselves is they're going to actually trigger callbacks that are given to them, right? So those components, they're completely independent from your application. They don't know what your application is for. They don't know what kind of state it has. So an example of this would be, let's say, if you're doing a date picker doesn't know what's the meaning of the date it's picking, right? You just can set it into a particular state. You could say, here's the month that you should be displaying right now, and it then just whenever the user clicks on a date, your date picker basically needs to fire an action and says, here is the date, right? So those are components. Now you contract them with containers, which is sort of larger components that actually hook with your application, that have access to your business logic, right? So in this case, the rule of thumb is you probably want your route components to be containers, so that basically things that correspond to different routes would actually have access to the state of your application, who will get connected through Redux in this case, while all of their children components will be dumb components. They will just get their inputs through properties. So in this case, we have a larger component called main page, and that's going to be our container. It has within it all of the individual nodes and all of that stuff. And what we're going to do is, the way we're going to connect is we first call connect with two arguments. First one is a function called map state to props, and this maps parts of Redux state to properties that will to properties that are going to be fed into main page. And the second one is called map dispatch to props, and what this will do is it will attach properties to it will add callbacks, handlers, to the properties that are sent to main page, which will correspond to functions that, when called, will dispatch some actions. So here's how this looks in practice. This is a simplified example. So when we want to map state to properties, we will receive state as when this function is called, and we'll start here by taking the nodes section of that state, converting it to JavaScript, to just a plain JavaScript object, and then we'll return an object that basically has a field called nodes that, in this case, has some transformation of that state. In this case, what I'm doing is I have an array that has all of the IDs in the order in which they need to appear, and it has an object that has all of the data keyed by ID, and I'm just sort of flattening this. As a general approach, you probably, as you map states to props, you want to simplify things and really at this point give your user, give the component that you're going to be passing this to something that's really easy to use. And it, again, remember that the component is not going to have any way of modifying that data structure. So in that sense, you don't need to optimize this data structure for long-term maintainability. So, and then the second one is map dispatch to props. What we here want to do is we want to make sure that the component will have, one of its properties is going to be a function called onContentChange. And when the component triggers that function, then we will call this corresponding function, which takes two arguments, a node ID and new content, and it will create a new node content action with those arguments and dispatch it. So basically, if we call the onContentChange on this component, then the end result of this will be that an action, the update action, is going to get dispatched. So that we'll basically be passing on. So when it's inside of our main page, we'll have onContentChange, which is what we're going to actually call every time the content of some node is changed. So this is really it for React. Now I skipped a couple of small details that are the same for React and Angular, so Evan will cover those as he talks about Angular.
Hi, yeah, so for the next bit, I'll be talking about using Redux with Angular 2, and the library that I'll be using for the bindings for it is a library called ng2 Redux. The author of this also made the ng Redux bindings for Angular 1, so a lot of the concepts that I'll be going over here can also apply to Angular 1 as well. So like with Redux, where Redux had the map state to props, with Angular, it's more say map state to this or map state to a target. So one of the first things that we have to do, and the similar work has to be done in Redux also. But first is kind of creating the store that will be used throughout the rest of your application. This is where you register the reducers that you've created for handling the various slices of state in your application. And this is also where you can create or register the middleware that you want to use. And middleware can let you return things other than JSON objects, provide logging. Middleware is also it plays a role in driving the debug tools that Yuri showed before. In terms of Angular 2, once you've configured the store, you have to register it with the application. So in Angular 2, when you're bootstrapping an app, this is like our main root app component, and then this is the store that we created in the previous slide. So, for example, with using this with Angular 2, in this example here, we are creating a component that will keep track of how many times an item has been clicked to either increase or decrease the value, and then also want to check if it's odd, and also do an asynchronous event. And one of the things that you'll notice here is that our counter class is basically an empty class. There's no logic being done here. Its sole purpose is basically to render data and then invoke the callbacks that were passed in. The next thing that we'll want to do is kind of create our container component. This could be a component that is living on the top level of a route. And then this is the component that kind of knows about Redux, it knows about the state and how to dispatch actions. And using the new Angular 2 syntax, we're passing in a counter and then also some events to increase or decrease the value. Now, how we get Angular 2 to be aware of this is the ng-redux.connect. So connect is very similar to what is being used with Redux, where you have where you pass in two functions. One is the map state to this, and the other one is the map dispatch to this. One thing to keep in mind with Angular 2 is that we still need to unsubscribe once the component gets destroyed. And with the Angular 2 lifecycle, there is the ng on destroy. So unlike Angular 1, where we had to use scope, you don't have to worry about that with Angular 2. So let's take a quick look at the mapping methods. So just like in the Redux example, the map state to this, it takes in a piece of your application state and returns a object. And in this case, we now want to have a property called counter that is available to be passed into our component. The next one is our map dispatch to this, and this is what will map our action creators, place it onto the component, and they are available to be called.
Well, and finally, I guess we want to have some caveats about Redux, because obviously no tool is perfect, and Redux has its challenges as well. First of all is that it's addictive. Once you start using it, you can't really easily you cannot really stop. That's been experience of pretty much everyone at Rangle.io. It also means that you're not going to be actually happy using anything else, and this is sometimes a factor to consider. You're not going to if you actually then have to work with something other than Redux, you may just find yourself very unhappy, and your friends might not understand your obsession with Redux, and so you may potentially lose some friends over this. So with all that said, we thank you very much, and we are going to start looking at questions now. Give us a second to pull them up. So we have a question of whether it supports optimistic UI updates somehow. We're not quite sure what was meant by this question, but one thing that's worth mentioning is that the ng2 Redux does not currently take advantage of absolutely everything that Angular 2 offers you in terms of optimizations, but this is something that we're actually looking at actively, and Evan is looking sort of into the depth of ng2 Redux in terms of what to do what we can do there to really make sure that we take full advantage of what Angular 2 can do in terms of its view update logic. So this is something we're hoping. Do you want to add something on this?
Yeah, and then also in terms of like the optimistic UI updates, if you've been kind of updating the UI before maybe an operation is successful or not.
Oh, I see.
Yeah, so kind of one way that can be handled. There's nothing in the framework that will do that for you out of the box. But for example, if you're dispatching an action to the server and then want to maybe navigate to the next screen, what you can do is to dispatch an event to say that an action is happening, and then navigate, then update your application state to show kind of what you hope had happened. And then if there is an error response, then dispatch that action again and give the user an option to roll back and go back to where they were before.
So yeah, I guess in some ways you could say that it's similar to how you would do it with other setup, but where I would say the difference here where Redux helps you is that it makes it a lot easier to remap those things, right? In the sense that you could basically say that we're going to fold the data structure in at the time. So you change this logic in your reducers, right? You could basically say we can fold it in response to actually confirmation from the server, or we could change this in response to an action that just simply says we're going to ask the server to save that data. So I think this remapping ends up being a lot more flexible. I think in that sense, if that's what we mean by optimistic UI updates, that does become a bit simpler. We're looking at the next question, sorry. So there is a question, so it says if you want to have modular reusable components like a date picker, how can you implement that component so that different parents can control separate instances? if your module has some action creators like change thingy and change thingy A, and you have two instances of that component on the page, how do you? So you would, in Redux, you would not tie things quite as close to components, right? So what you would want is you would really want to actually kind of start with understanding your data structure, right? And say, okay, well, we want a date here and we want a date picked there, right? And then, so in that sense, they will logically, for me, be separate dates, because one of them is set invoice date and the other one is set, something else date.
Yeah.
What's your reading of this question?
Yeah. So I guess let's say if there is like a invoice date and a bill date, you'd still have like the same DOM date picker component, but the data and the actions that you would pass into the separate components. One would be passing in the invoice date and then maybe change the invoice date. The other component you have, you'd be then passing in maybe the bill date and then change bill date. So in the counter example, you can see where I was like passing in counter, increase, and decrease. That component doesn't really care where that data came from; it just cares that has it provided. So that is how you could have like the same date picker component being reusable on multiple parts within the same screen.
So there's a question of someone says they are late, and there's a question of will we be publishing this, and the answer is yes, possibly in a week or so. Then there's a question that says you mentioned two approaches to async but only covered one. Yes, so that is true. Let me explain this part again. So there's two kind of common approaches. One is that you handle your synchronous stuff in side action creators. That makes your action creators a bit more complicated, but at the same time, it's a much easier approach to understand. So, which is why we focused on this approach in this presentation. There is a second approach which relies on a context of middleware. Now, we didn't want to get into the details of middleware in this presentation because it's a bit of a long story. But basically, Redux has a way for you to have middlewares that basically just create actions in response to actions, and that can work asynchronously, and that is the other place to put your asynchronous code, and probably I would say on the balance a better one, but it's a somewhat more kind of advanced topic. So my recommendation would be that you probably want to start with putting it in action creators for your first application, and then look into middleware down the line. So the only source of async. So there's a question of, is dispatch synchronous like reducers? So the only source of asynchronicity here. So there's two potential sources of asynchronicity. So your action creators can create actions in callbacks, and you could do middleware. So when you introduce middleware, then your dispatch cycle is no longer quite asynchronous, because you could have, or in the sense that you could actually have asynchronous actions triggered by, or you could have additional actions triggered asynchronously in response to actions. But we, as I'm saying, decided not to get into details of middleware here.
Yeah. And then also, let's say if in your actions, if you have a promise to make an API call, like the final dispatch that gets sent to the store is just going to be like the plain JSON object, not the promise of a request. This one, TypeScript typings for state object, recommended or not recommended? What's your take on this? This is something that we've been currently experimenting with a bit more here. And I've also been following a PR on Definitely Typed for better typings for the state object. I think once that PR gets merged in, I think it would become recommended, because it would allow you to kind of have, to make use of the TypeScript generics to have a strongly typed state. But I think until that PR is merged in, I think the current typings are a little bit limited right now.
Where does RxJS fit in the stack? So your need for RxJS solves a problem that you, for the most part, end up not having with Redux, right? So it's an alternative solution in that. So if you're not using Redux for a lot of Flux-driven approaches, you will end up using RxJS like everywhere in your code. Like everything is going to be streams. Which is, now as far as it's not a bad way of handling asynchronous data flows, but it's not nearly as nice as what you get with Redux. And so with Redux, what we've been finding is that your need for like 95% of the times when you would be using RxJS are now gone because you have synchronous actions instead, reducers instead. Now, you will still need things like that in certain targeted contexts, right? So, for instance, in the application that I demoed, there is a debounce on the saving, right? So as you type, it saves the content, the updated content, but we want to debounce that because we don't want to be actually sending it to the server after every keystroke. So, what's the easiest way to do a debounce? Well, RxJS comes to the rescue, right? So, and if you are interacting with the server, you may well find yourself either using promises or using RxJS, but ultimately it's going to have a very sort of limited space in your application. It's not going to dominate your architecture as it does without Redux. Fair. Will my router state in Angular also be part of the Redux store?
Yeah. So currently, out of the box, there's nothing there that will keep your router state in sync with the store. If you're using Redux with Angular 1 and UI Router, a coworker of mine, Neil, made bindings for UI Router for Angular 1 and Redux that will keep things in sync. With Angular 2, nothing exists like that yet, but it is something that I am looking into being able to create soon.
So there's a question that says, can you share a link to the browser debugging tools that you demoed? It's called Redux Dev Tools. I think if you just Google Redux Dev Tools, you'll find them. And then they're linked, I'm pretty sure, from the Redux main Redux page. We have another question about Rx, but it's basically the same thing again. So you don't really, for the most part, need it, though there may be some cases where you will. We've talked about the two different approaches to asynchronicity. Another question about this. That's a good question. So would the DOM component itself ever dispatch an action? So this is somewhat of a open question, I guess, for me, in that we've gone sort of both ways on this. We felt in the past, and I suspect it might be a little different between Angular and React, potentially. With my own experience was that there were a few months ago, we felt like there were valid cases where you would actually want to dispatch actions. When you're working with Flux, I think that often seemed like a good idea. But when we've been working with Redux, I guess at least for React applications, I think we've been increasingly moving towards being more strict about and really making DOM components dumb. Evan, what's been your experience?
Yeah, there was a time where I was kind of playing around with thinking it might not be that bad of an idea to let a DOM component dispatch its own event, but after a bit more experience, I'm kind of leaning towards just passing down the callbacks and not having the DOM component kind of be aware of what the actual action needs to be. It just needs to be aware that it has a callback to a call.
And I guess at least in case of React Redux, it actually doesn't give you an easy way of doing that. So like you either connect your component to Redux or you don't. So you can't really have connected. And in that sense, I think at least with React Redux, we haven't been doing this. What is the workflow in Redux to implement something like promise.all? So I would say that if you're having a situation where you need promise.all, you probably should be using promise.all. It's only quite so it doesn't eliminate all of the need for your promise related code, right? So it's just that you will want to push it down into a library, right? Like where, I mean, maybe you need, the user submitted, filled in a giant form, now you want to submit it. Submitting that form requires you getting results from 75 different endpoints, and then calling another 50, right? I mean, if you need to do all of that, you're gonna have super complicated logic of dealing with your server, but you could take all of that and use promises or whatever, but then push it all down where when it integrates into your application, you'll have a function called submit form. Evan?
Yeah.
Similar? If the only proper way to use ng2 Redux, so can we easily write something for ourselves?
So you can easily write something for yourself. The ng2 Redux, I think, is maybe a few dozen lines of code just for wrapping up a few of the Redux calls. It is fairly lightweight, so you could write your own type of implementation for it. And I've also seen a blog post recently that was using a different kind of connector library, although I forget the name of it offhand. ng2 Redux is not the only proper way. It's just the way that I have the most experience with right now, and it's the Angular 1 version I also have experience with, but you are able to write your own.
So we're past 1 o'clock, but we have still a few questions, so we'll stick around and try to answer as many as we can. There's another question that says, why wouldn't I just call dispatch directly from my UI component? You could, again, so this is an approach that I guess we don't take a very strong religious position on. We are currently leaning against this, but we were taking that approach as valid, I would say, not that long ago. So, but no, if you're using at least, can you actually do that with ng2 Redux? Because React Redux really just doesn't give you an option of doing that, I believe.
With Angular, you could call dispatch directly from your UI component. Some of the reasons why you might not want to do this, though, is, for example, it is now kind of like tying this dumb component to having a reliance on Redux or something with a dispatch. So now this kind of reusable thing that you could plug into anything and not be reliant on Redux is now being bound into Redux. And then if you're calling dispatch and the explicit action type, if you did want this component to be reusable for different things and be able to handle the different actions, by calling dispatch from your component, you're now kind of having a tighter coupling between those two. If it's a case where this component is never being reused, it's this really one-off thing, then you might then there could be a case for that, but it is something I would recommend avoiding.
So we have a question. If we had something like our to-do list and wanted to now make our app multiple lists, do we change all of our existing components to now include a list ID, or is there some way of? So now from React perspective, let me answer this from React perspective. So you would not really want your individual components to know what I guess no, they will have a list ID in the sense that this is what the updates are going to get sent with. In that sense, I'm not sure what's the downside and why we want to avoid that. But usually, if you're going with React approach, you will be receiving the entire list of current list items every time, so you will not ever be modifying. So in that sense, the existing logic, there will be actually not much logic in your component anyway. What's your take in regards to Angular 2?
because I think with this, if you were to have multiple lists and then multiple reducers, it's like kind of like a add to do and add grocery item. This is where kind of like by not having your say components calling the dispatch itself, you could have the same list component and then just the one for the to-dos, you'd pass in the state.todo, and then for the one that is like the other item, it'd be like state.groceries and the callbacks for managing that list. That's one way that you could kind of do that.
So another question is, are there any notable drawbacks to using immutable data? So from my perspective, when it comes to using immutable JS, one drawback that I kind of found early on, but that I think is going away partly, is that you're working with data structures that are not normal JavaScript data structures, and so you can't really do, you cannot just sort of use them in some cases. So for instance, one fairly dumb example is that when you open your when an earlier version of React DevTools was not aware of immutable JS. So when you will see state, it will kind of give you the state, like it will literally show you the immutable JS data structure. And this was actually really kind of hard to navigate with. So you will be able to open your state, but you'll just see all of those sort of internal, auxiliary data structures. And really, right now, this got fixed, where the new version of the tool that I showed you, that it actually is aware of the fact that it may be immutable JS, and then it kind of adapts the display for that. There was a similar issue earlier with earlier versions of Angular 2, I believe, where you couldn't, for instance, iterate over, like naturally use like standard ng4 for immutable JS collections, but I believe that's being fixed, right? Varun
has that fixed in our training, but and then go to like there's a better ability to iterate over the collections. I think one of the drawbacks that I found was when I was just getting used to working with immutable JS and immutable data is kind of, if you're not careful, you can still introduce mutable parts of your state and not realize it. So I think kind of just getting over the kind of mental hurdle of using immutable JS properly is a minor issue, but it can be learned fairly fast.
So there's a question, isn't single state is going to be very hard to maintain as it grows big, just as the models in the traditional model? So the fact that it's single state actually is not that much of a problem, because you will actually have that split into multiple reducers. And in the sense that no one reducer is going to actually get the whole state and be able to modify it. And then the second thing is that a lot of your problems actually go away when you control the changes tightly, right? It's when you have everything in one place and anyone can change them, then you have problems. But in this case, the ability to change items in your state are actually fairly restricted.
So the next one. The next one is asking about the time travel debugging and hot reloading in Angular 2 with Redux. You can actually use the Redux dev tools that, even though they're built in React, you can actually have them work in Angular 1 and Angular 2. If you look at the repo for ng Redux and ng2 Redux, the author has included an example of how to be using the Redux dev tools, which will give you that kind of fast forward, rewind, and that. For the hot reloading, that isn't working quite as smoothly yet, but I have seen a alpha release for an Angular 2 hot module reloader. I haven't had a chance to experiment with that yet, but it is in a early alpha state.
So there's another question about slides. Yes, slides will be, or the video is going to be available. There's another question about RxJS, which is sort of similar to the one we answered. There's a question of, so then a complete modular component does not implement its own action creators, it's just dumb React view. Yes, that's exactly. And in fact, we've been moving towards not just dumb React views, but like super dumb React views. At least when using React, what we've been finding is that in the kind of classic React, there is this idea that you generally speaking don't want to put too much state into your component, but there is a certain things that are kind of legit to keep a state in your components, as long as you're very judicious about it. With Redux, we've been finding ourselves more and more just taking the approach of just no state in components, period. Or at least making that very, having exceptions to that in very, very limited cases. The reason is because if your component just simply renders a Redux state for just everything, then suddenly you have the ability to actually debug the internal state. Like if you introduce internal state of the component, suddenly that's not debuggable through the same tools, and it just makes it more difficult to deal with. And so we've been finding ourselves more and more, at least on the React side, moving towards the situation where it's just Redux is the only place where any sort of state is stored. Angular, I'm not sure what's been your experience. Not quite as... Angular is a little bit more stateful by nature, so I imagine you probably wouldn't go quite as radically with it.
Yeah. Yeah.
More high-level question. Our development team has been using React for a year now, but we've been growing frustrated with having to keep up with all of the changes and never being confident which Flux implementation will win out, and even has considered switching to Angular in hopes of more stability. We have not really tried out Redux, but it's winning, and but is it winning, and how confident are experts such as yourselves that it will be here semi-long term? Do you view it as the future because you see it being... I understand your frustration there, in the sense that there is being a lot of change in this ecosystem over the last month. It's been really kind of a wild ride, and to a point where at times we find that, there's best practices change really by the month, so you can talk about here's the best practices as of July 2015 versus here are the best practices of August 2015, and they're not necessarily the same. I don't know if you have stuck with Angular, whether you would have necessarily been in a better situation today, because obviously with transition to Angular 2 is a pretty big one, and furthermore, I think in some ways, while Angular 2 makes a big effort into doing the transition from Angular 1 to Angular 2 not insanely painful, but at the same time, there is conceptually Angular 2 is actually more aligned with React, I would say, than it is with Angular 1. So in that sense, if you actually wanted to convert a React app to Angular 2, it might be an easier task to do that than converting an Angular 2 app. It will need to be a little bit, there's less tools in terms of supporting you in the halfway point, which is something that Angular 2 does quite well at this point, but conceptually you'll probably actually need to rewrite more code, I would think. But unless you've been doing Angular 1, sort of the Angular 2 style, as we've kind of been advocating over the last few months. In terms of whether Redux will be winning, that is... I know that's no one knows what's going to happen in the future.
Yeah, although interesting thing about Redux though is, as you could kind of mention at the start, is that Redux itself is framework agnostic, which is how it's able to work with, like, say, Angular, React, or any other framework that you want. So this kind of helps give you a bit of a future proofing in that a large part of your application is now not bound into, let's say, the framework that is driving your view. And also, in terms of Redux...
and it's not a huge framework.
No, it's without all of the, like, say, kind of edge cases and comments on that, it could be boiled down conceptually to about 90 lines worth of code.
Did you say 90?
Yes, the creator made a gist that had, like, the core concepts of Redux, minus a few, say, edge cases and, like, the defensive type checks, but the core concept can be boiled down to about 90 lines of code. And also, he's considering that Redux 3.0 is pretty much final, which is very rare in the JavaScript world that you hear a final version. And I've also seen a few of the other Flux implementations floating around that have decided to say they're discontinuing their support on this one and pointing to the Redux documentation.
But I guess, to be honest with you, I just want to answer the last question explicitly. I mean, so you're asking, do we view this as the future because of it being most used? No, we feel that this is the future because we think it's the best solution that we have seen out there that is better by leaps and bounds than other approaches we've seen, right? But on the flip side, could it be that someone next year is going to come up with an improvement upon Redux? It's entirely possible, but I'm guessing that whatever new things are going to come, they're going to be building on that, and in that sense, migrating to them from Redux is probably going to be a lot easier than migrating to it from other approaches. Yeah. Have you had the chance to compare ng2 Redux to NGRX store?
I just kind of came across the NGRX store yesterday, so I haven't had a chance to look into it yet, but I'm curious to see what their approach is and how it differs from ng2 Redux.
Are there good sample projects that I can play with? The answer to this question is yes. So we at Rangle, we have built starter kits for Redux with React and Redux with Angular. So if you go to our GitHub page, it's github.com/Rangle, then you'll find them there, and they're sort of simple examples, but they do all of this setup for you, so you can really copy this and then start building your application with it. So I would say those are good things to play with. When you eventually need to save data, do you dump the store into a large JavaScript object and send it off to the server in Redux? No, you do so Flux is a little bit less, there's more variations on Flux, right? But I would say that Redux handles that scenario in the same way that the dominant recommended best practice with Flux is today, which is that you will actually send your objects to the server before they hit the store. Right? So it's not the store's responsibility. The store in this case, actually, you don't even control the store much. You will send them as part of Action Creator, or you will do that from middleware. Yeah, fair?
Yeah.
Are there any, mutable data, we've answered that question. Doesn't using a single store become very complex? We've answered this one. How directly related? There's a question of whether we'll be doing a session between mobile Angular versus React Native. We will definitely be doing, I'm not sure we'll be doing this as a single session of one versus the other, but I'm pretty sure that we've got React Native webinars in the pipeline, and we'll probably be looking at mobile Angular within, I would say, reasonable time. Since there's one big state object, is Redux a good choice to use with real-time applications where we have to handle several data on the screen? I don't see, yes, because you actually, so I mean, in generally speaking, JavaScript, there is not a problem of having a lot of data, right? Because your browser can actually handle a lot of data. It's when this data gets projected onto the screen. And what you could do, so with Redux, you only expose chunks of your, so the fact that all of the that you have all of the data in one big state doesn't mean that every component sees all of it, right? Your components will see a small slice of it, and in that sense, most of this data is going to get hidden from your screen, and the fact that you are, that's not a problem. No. So you will never want to actually give your component access to everything. You'll want to control this, but if it's several data points on the screen, then you could feed that, from. Last question, why Redux and not Flux? So, well, I mean, I guess there's a sort of a semantic argument of whether Redux is Flux. I mean, some people will say that Redux is a type of Flux framework, and I kind of think it's pointless for us to get into it. Alternatively, you could say that it takes as Redux Flux ideas to the sort of logical extreme. logical conclusion. From my perspective, I mean, Flux is, there's a few different ways of doing Flux, and none of them, other than Redux, unless you consider this a version of Flux, to me really get the same conceptual clarity and elegance. And in particular, most versions of Flux require that you deal with streams, which is sort of a big downside, and they don't really let you put most of your code in pure functions. Evan?
Yeah, and also, and this is actually after talking with a few people here that have more hands-on experience with, say, traditional Flux, and kind of a lot of the problems and kind of, say, questions that they had while trying to use more traditional Flux patterns, such as where do I handle side effects, where do I deal with asynchronous actions, and things like that, kind of, with a lot of them, kind of the solutions that they ended up kind of honing in towards ended up being really close to what Redux was offering. So kind of when they come up with the answers to like how do I handle async, and do I have, say, smart actions and dumb stores and things like that. Once they kind of got to Redux and saw Redux, it was kind of like, oh, this is kind of how I was ending up doing things anyway. So like what Yuri mentioned earlier at the start, we're kind of say Redux kind of just seems like the logical next step with Flux.
So this was the last question, and I guess we're 20 minutes past our intended time. So I want to thank all of the people who attended, especially those, as quite a few of you who actually stayed all until this time. So thank you very much for sticking around until the very end. And stay in touch. We'll be doing more webinars, so come for more. We'll be, also just get in touch with us through Twitter or other things. So my Twitter handle is on the screen, as is Evan's. Thank you very much.
Thank you.